Hello everyone. In this video we're going to be solving a cubic equation. I'll be presenting two methods, but one of the methods does not work. Why doesn't it work and why am I showing it? You'll see in a little bit. Let's get started with the first method. For my first method, I'm going to divide both sides by 4 to get a monic polynomial. Monic means the leading coefficient is 1. 2/4 is 1/2. So we get our monic cubic. Now we're going to be using Cardano's formula, but I'll explain the process. So it's fairly easy to understand. It's a really powerful method for solving cubic equations. But in order to be able to use the method, we do need the coefficient of x squared to be 0, and it is already 0. So that's good. If it wasn't 0, we could use substitution to get rid of the x squared term. All right, so here's what we use. Consider the expansion, the binomial theorem for cubics, a plus b to the third power. You know that we can write this as a cubed plus 3a squared b plus 3ab squared plus b cubed. But we could also arrange these terms a little bit to make it more, I don't know, just put it in a nicer way. A cubed plus b cubed, and then put the 3ab terms together and factor. And then here's what I'd like to do. To be able to use the Cardano's formula, I'm going to isolate the sum of two cubes. So let's go and subtract 3ab times a plus b from both sides. So basically from now on you can always use this identity. You don't have to derive it every time. This is equal to a cubed plus b cubed. So here's how the method works. I'm going to call this my x. So a plus b is equal to x. And then by comparing this equation to the other one, so I have x cubed minus 3abx equals a cubed plus b cubed. You can also put a cubed plus b cubed on the left hand side, but I just didn't want to subtract it. So now if you compare this equation to this one, you'll notice that the coefficient of x here is negative 3ab, and the coefficient of x here is negative 3/4. And the constant term is on the right-hand side, so we're going to go ahead and add 1/2 to both sides of this equation, and we're going to get x cubed minus 3/4 x equals, and we have 1/2 on the right-hand side. Awesome. Now, if you compare these two equations, then you're going to notice that we can find the ab values from here, and that's basically the essence of the method. Finding a and b, and you're going to solve the quadratic for this. And then by using that quadratic, we're going to solve the cubic, because we know that x is a plus b. So we can get the x value. If you can find a and b, then we can find the x value. So let's go ahead and proceed for solving this equation. So this gives me negative 3ab equals negative 3/4. And from here we get ab equals 1/4. And by cubing both sides, we get a cubed b cubed equals 1/64. I do need to cube both sides because I want to use the sum of cubes. And a cubed plus b cubed is basically equal to the constant on the right-hand side, which is 1/2. So this gives me a system of equations, and this becomes a quadratic system in a cubed or b cubed, whichever you want to use. So from the second equation, I will isolate b cubed. So I'll write it as 1/2 minus a cubed and substitute that into the first equation, and that is going to give me a quadratic. But first of all, let's see what that gives us, because it's going to give us a 6th power, but we'll turn it into a quadratic. So a cubed multiplied by 1/2 minus a cubed equals 1/64. Now let's go ahead and distribute 1/2 a cubed minus a to the 6th power equals 1/64. Let's put everything on the same side, making the a to the 6th positive. And this is what we get. So this is our quadratic equation if we call a cubed something. Since I have b in my system, I want to call a cubed c. Okay. C is not a constant, it's a variable in this case, right? Or whatever. So in this case, we get c squared minus 1/2 c plus 1 over 64 equals 0. And this is the quadratic I was talking about. Okay, so we're going to solve this quadratic. Very easy to solve by using the quadratic formula or completing the square. Or you can also use the Poche and Lowe's method, which I recently made a video on. You can also check that one out. Okay, anyways, so let's go ahead and solve this equation. C equals negative b 1/2 plus minus the square root of b squared, which is 1/4, minus 4ac. And 4ac is just going to be 4 times 1 over 64, which is 1 over 16. And the whole thing is divided by 2. Alrighty? So you have two alternatives here, actually. If you don't want to solve it like with fractions, you can multiply both sides of this equation by 64 and proceed it that way. How about using that way? I mean, I think I like that better. So let's go ahead and do that. Multiply everything by 64. Get rid of all the fractions. Who likes fractions, right? Okay. So now let's go ahead and use the quadratic formula. Negative b plus minus the square root of b squared minus 4ac. I know some folks are thinking like, why did you multiply by both sides by 64? Because that made the numbers much, much larger. But that's okay. We're going to take care of that. So inside the radical, I want to factor, so we can use a little bit of factoring here. 32 squared can be written as 16 times 16 times 4, because 16 times 2 is 32. And 4 times 64 can be basically written as 4 times 16 times 4. Now this is cool because I want to find a common factor, which is a perfect square at the same time. So 4 times 16 happens to be a perfect square. So it's kind of like 64 times 16 minus 4. Or inside the radical, we can factor it as 64 times 12. But 64 times 12 is 64 times 4 times 3. Therefore, it's just going to be 256 times 3. So that expression turns into a perfect square times a prime number or whatever, which is easy to take care of. Now, let's go ahead and plug it in. We have now the square root of 256 times 3. I could easily take it out, but I just wanted to take an extra step here. Let me erase that. It's too crowded here. So let's go ahead and write it here. C equals, I'm still on the eraser, 32 plus minus the square root of 256 times 3 divided by 128. That was the bottom, right? Okay, great. So now 256, the square root of 256 is 16, right? So that gives me square root of 256 is 16, and I just have a 3 inside the radical. Now, this is good because I can go ahead and simplify. The greatest common factor is 16, so I can divide everything by 16, and that gives me something real nice, 2 plus minus root 3 divided by 8. So those are the c values, but guess what? We don't need the c because we do need x, but for x we do need a and b. For a, we can use this equation. A cubed is equal to c. All right, great. So which one are we going to use? Doesn't matter because a and b are interchangeable because x equals a plus b. You just pick one of them to be a. Let's just say, hey, c equals a cubed, and let a be the positive one, right? And b is going to be the other one. I mean a cubed and b cubed, right? So a cubed is equal to this, which means a is equal to the cube root of 2 plus square root of 3 divided by 8. Now remember, that's a cube root, so I can basically simplify this as the cube root of 2 plus root 3 all over 2. Awesome. And b is going to be similarly, because c is also equal to b cubed, and b is just going to be the other root cube rooted, so that's going to be this one, and from here b becomes the cube root of 2 minus root 3 over 2. Since x is equal to a plus b, now we can find our x value from here. Something is coming up too soon. So let's go ahead and write x as a plus b, and that just gives me, since they have a common denominator, x becomes the cube root of 2 plus root 3 plus the cube root of 2 minus root 3 divided by 2. And that gives me the real value of x, but are there any other real solutions, and how can we find that? So for that, I'm just going to give you what Wolfram Alpha gave me in terms of solutions. So we're going to go ahead and take a look at that. And then we're going to also look at a graph, but first let me show you what the exact solutions are. And then we're going to look at the second method, which does not work, by the way. All right, here we go. So here's the real solution. As you can see, pretty much the same thing, but they wrote the -1 first. I don't know why. And here's the other two solutions that are complex in exact form. If you click approximate forms, then you'll get the approximate solutions. But on the graph, I'm going to go ahead and show you what the exact solutions are. Also, cubic equation calculator gives us the solutions like this. But before we move any further to the graph, let's go ahead and talk about the second method. I think we have more room here, so let's go ahead and use this page for the second method. For the second method, and remember I told you earlier that it's not going to work. Why doesn't it work? All right, it doesn't work because of trigonometry. Trigonometry is to blame. Okay, so here's the second method. I'm going to call x cosine of alpha. And there's a motivation behind it, because if you plug in cosine alpha for x, you get 4 cosine cubed alpha minus 3 cosine alpha. And this is equivalent to cosine of 3 alpha. So anytime you see 4x cubed minus 3x or multiple of that, and here's another video that I made on this topic, you can always plug in cosine alpha. But when you set it equal to 2 and replace this expression with cosine of 3 alpha, you run into a problem. Why? Because cosine has to be between -1 and 1 inclusive. So cosine of a real angle cannot be 2. Can it be complex? And can we find the complex solutions from here? That is a good question. That is for you to think about. But we don't get any solutions from it. That's why this method does not work. And let's go ahead and take a look at the graph, and we're just going to wrap it up. Here's the graph of 4x cubed minus 3x minus 2. As you can see, we have one real solution, which is approximately this one, and the other solutions are not real. And notice that the maxima and minima are very interesting, because those are like fractions, and you can easily find them by differentiating this equation and setting it equal to 0. So if you differentiate y and set it equal to 0, from here you're going to find the x values for the maximum and the minimum. And this brings us to the end of this video. Well, thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. It was a little long video because we had to talk about a lot of different things. I hope you enjoyed it. Please let me know. Until tomorrow, take care, be safe, and bye-bye.